Hello. Now I will be talking about our online programming event, and this year as the online event we have our very own, very traditional and yet very innovative Mission Mars. We have been conducting Mission Mars for the past 3 years, and this would be 4th year we are going ahead with Mission Mars. And the reason we keep continuing with this event every year is we get such innovative ideas and algorithms from you every year, and this coding event has a scope for so much innovation in itself that we are going ahead with Mission Mars this year yet again. So what is Mission Mars all about and why Mission Mars? Well, man has landed on moon, fine, and we have also taken the first step towards Mars. Already many robotized vehicles, some robotized vehicles have been sent to Mars. So if we are taking a new step towards Mars, what can it be? Sending one big robot every time is not an answer. It's very expensive and it's not that efficient. So from the point of view of efficiency, what makes sense is we send many small robots. And how do these small robots coordinate and communicate among themselves, how they help each other to cover as much of the Martian surface as possible, to send feedback about as much of the data as they receive. This is where Mission Mars is inspired from. So if we are talking about communication and coordination, which is what we are concentrating over here right now, then our inspiration, we draw inspiration from one of the finest examples that we see in nature, ants. Yes, the streak of ants that we see daily, that irritate us almost daily, that is, if looked closely, give an inspiration to how small ant robots, if I can call them, these small ant robots should coordinate and communicate so that they can send us the data as and when they cover the Martian surface. So simply put, the task of Mission Mars is, Mission Mars, our online programming event, the task of Mission Mars is uncovering as much of the Martian surface as possible in a given time constraint. Please note that the time is a constraint in Mission Mars. So how do these robots come and uncover the Martian surface? Well, the Martian surface itself is a server program, that is a GUI based server that provides you a graphical representation or visual simulation of what the Martian terrain can be or is like. The map sizes this year may vary. We will take as an example, let's say a map of 600 cross 600. So if you have a 600 cross 600 map, that basically means you have 600 grids, these squares in x direction and 600 squares in y direction. So what basically means is your robot starts somewhere in one of the grids, and then starting from there it has to uncover as many squares, as many grids as possible. So what's new this year? This year we have two kinds of robots. Usually we have one, this year we have two. We have an explorer robot and we have a communicator robot. Now the difference between the two is, as is quite visible from the name itself, an explorer robot will have a larger vision radius. It will be able to see far and wide as compared to a communicator robot. A communicator robot, on the other hand, will obviously have a larger communication radius, so it can send signals to bots which are further away than itself. So a communication robot may not be able to see as much, but it will be able to tell other robots about things which it sees. So this is the most major modification that we are making to Mission Mars this year, bringing in two qualities of robots. Now all the robots will have the same code. You will be submitting just one code to us, and we will be compiling that code and running multiple copies of it. So all you have to do is submit one code in either C, C++ or Java. We will compile that code and run, let's say, 100 copies of it. So the objective that you have to achieve is maximizing the number of squares, that I talked about. That many squares, as many squares you cover, that more efficient your program is. So we will decide how many bots you have to run, how many copies we are running at the time of the event, that is just before the event, and we will be specifying it in due course, like if we are running 100 copies or 50 copies or 125 copies, how many, that will be telling you in the due course. Now the starting position of each robot, like if you are running 100 copy, where each of the 100 robot is positioned, the starting position of each robot is decided randomly by the code. We are not having any interference as to where the robot starts, it's all random. A robot can move in 8 adjacent directions. So if we say a robot is over here, in a single step a robot can go either here, 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 or in one of these. Any of these 8 grids the robot can move into. all the bots make their move at the same time in the same cycle, which basically means if I have a bot over here and if I have a bot over here, in one step both the bots make their move. So, if this bot wants to move here, it goes here, if this bot wants to move here, it comes here. All moves are made at the same time. Now, there are certain cases that you have to be aware of, and in these cases, that is when a robot is declared dead or is considered dead or extinct. Now, there are conditions when these happens, and a few of those conditions are like there are various landforms or terrains on the Martian surface. There can be a cliff kind of a thing, or there can be an obstacle kind of a thing, a boulder kind of a thing, which we are depicting. So, if a robot hits a boulder or an obstacle or anything that is a landform kind of a thing, that robot is considered dead. So, this basically means that if my robot is here and this is a landform, this part is a landform. So, if in a cycle this robot decides to go here, it will hit this landform and this robot will be considered extinct. What this means is that the program copy of this robot will be terminated. So, if we are starting with, let us say 100 copies of your robot, and at some cycle this robot decides to go here and hit a landform, in the next cycle you will be left with only 99 copies of your program, not 100, only 99 copies. Now, there are certain other cases where your robot may be considered extinct, and that is when there is a robot-robot collision. So, if I say you have a robot over here and you have a robot over here, in some step this robot decides to move here, this robot decides to move here in this step, such that in the next cycle they were both supposed to land up on the same square. In that case, there is a robot-robot collision, both these robots have collided, which means that the code for both these robots will be terminated. Both these robots will be considered extinct, and point to be noted is that this square that they were supposed to land on, this square would not be counted in the squares that you have covered. So, this square will not be counted when we are taking up your average score. Another kind of robot-robot collision takes place when, let us say I have a robot over here and I have a robot over here. If this robot moves here and this robot moves here, I mean plans to make these moves in this cycle, then also we consider this as a robot-robot collision, and in that case this square that this robot was supposed to move into, this square is not taken into your efficiency calculations. So, what basically means that till this cycle you had covered this square and this square, that will be taken into calculation, but this square will not be taken into calculation. Now, I talked about obstacles where your robot can become extinct. So, these obstacles also hinder the vision of a robot. So, if I have a robot at some point on the grid and it encounters an obstacle, it cannot see beyond the obstacle. So, if we take this example, I have a robot over here and I have an obstacle over here, that simply means that the robot cannot see these grids. So, if these grids were to lie in the vision radius of the robot, I will be coming into detail what exactly vision radius is all about. So, if this robot, these grids were supposed to be in the vision radius of this robot, if there is an obstacle over here, this robot will not be able to see these grids. This will be out of bound for this robot. So, if I have a robot over here and an obstacle over here, this basically means is that this whole thing will be out of bound for this robot. I cannot see anything that lies beyond an obstacle. So, even if my vision radius is high for a given robot, I cannot see beyond a point for the robot. Now, what area the bot can see and what vision radius is all about? Well, the vision radius of a robot depends on what height on the Martian surface the robot is located on. So, if we say the robot is on a Martian plane with associated height being 0, and if at that height the vision radius of the robot is 6, that basically means if you have a robot over here on Martian plane with height associated being 0 and radius let us say being 6, that means that your robot can see 6 grids in this direction, 6 in this, 6 on top and 6 on the bottom. So, that would give you a total of a 13 cross 13 matrix, 2 into 6 minus 1 plus 1 sorry. So, that makes it a 13 cross 13 matrix, and this would give the total area that you can see. So, at some point if your robot reaches a place on a mountain kind of a thing where the height associated is 3, then the vision radius of the robot would become something like 9, and then you can see a 19 cross 19 matrix in all overall. So, that would be like 9 in this direction, 9 this way, 9 this way, this way. We also have negative height levels, that is if you enter in a cliff or in a valley or a pit kind of a thing. So, you will reach in a negative height level, and then you will have a vision radius. If you have an associated height of -2, then you will have a vision radius of 4 only, and then you will be able to see just a 9 cross 9 matrix. So, the vision radius is important as to how much the bot can see. Now, all the bots will be able to send a local message at the end after each cycle. So, let us say you have a bot over here, you have a bot over here, they both see as much as they are able to see. After each cycle, they will be able to send a communication, they will be able to send a message to all the bots that are within their communication radius, and this is where the communicator robots come in. Communicator robots have a lower vision radius, but a higher communication radius. So, if this is a communication robot, even at height h is equal to 0, at a 0 height level, it will have a vision radius of let us say only 4. So, it will be able to see only a 9 cross 9 matrix, but when it is trying to send a signal, its communication radius will be, let us say R v is the vision radius, then its communication radius will be higher, and then it will be able to send a signal to the robots that are within its communication radius. So, for 6 a 13 cross 13 matrix. So, what this means is, this is a explorer robot, it can see a 13 cross 13 matrix, but its communication radius is less, and it can only communicate in a 9 cross 9 matrix. And communicator robot on the other hand can see only a 9 cross 9 matrix, but it can communicate in a 13 cross 13 matrix. What this means is, this bot cannot see this bot, but it can communicate with this bot. So, you have to take care as to how to utilize and make your communicator and explorer robot efficient. Now, for further details, please visit our website www.robotix.in. Once again, www.robotix.in. Till last year, we had our domains on a different website. Now, we have shifted to robotix.in. Please make note of that. We will be releasing our servers very soon. So, when I am talking about servers and I am talking about client, does that mean that you need to know networking? No, you do not. No knowledge of networking is required. Even if you know the most basic of C, C++ or Java, you can write this code. And this is the reason why we provide you with a client template. You do not need to know any networking beforehand. The networking part will be already written in the client and how it will communicate with the servers. All you have to do is write the function that we are asking you, the function of how the bot will receive, a function of how the bot will calculate based on its environment information where it is standing and calculate its next move. That is all you have to write. Also, the same for the communication, I mean what information it receives and what communication it sends. So, all this might sound a bit overwhelming, the servers and the clients coming in, but actually it is not. It is very simple, and you do not need to know any networking at all. Now, this is our website, as I said, www.robotix.in. We will be releasing this year's server very soon, but the site has the server of last year. So, what exact problem statement we had last year and what the server was like, what the client template was like, if you want to get a feel of it, please visit our website www.robotix.in to download. Even you can download last year's server and try a test code based on the last year problem statement. Whatever modifications we are making this year, and the new server will be releasing it very soon. So, please visit our website. Thank you.